Wonderful. So last week of October, let's take a look at our curriculum. If we go to our grade screen as usual, we scroll down, we can see that, oh my goodness, we're at the bottom of the screen, which means we're to the test. So we have a practice test and then test part one and part two. So the practice test, of course, is a practice grade, and it is available for you to make sure you're ready for the test. So let's go look at it. And oh, looky there, Mr. Brock takes the Module 3 practice test. So you have the practice test. So you can go through here and you can take it as many times as you want to because it's a practice grade. What's the quotient when you divide this by 6y? What's the quotient when we divide this by x plus 3, divided by x minus 2, divided by x plus 2. According to the fundamental theorem of algebra, how many zeros does this function have? What are the zeros of this function? What are the possible rational zeros of this? Oh, I love it. Since P is 18, is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13? Is it 36 different possibilities? Or can you narrow that down some? What are the possible number of positive, negative, and complex zeros? So that's Descartes' rule of signs right there. Which of the following represents the zero? So what are the zeros of this equation, basically? So how many questions are there? Looks like there are several. Going down, going down. Practice test usually has a bunch. 24. Kind of covers everything, gives you a little practice with all of it. Gives you a chance that if you take the practice test and bomb it, then you know, oh gosh, I need to go back and study. And these tell you where it comes from. Now, this is 4.07. That means it's actually 3.07. That means I've moved this from where it originally was. But that's lesson 7. Right. So you can go back and see if you're struggling on anything. Where'd that come from? This came from lesson 2. Right. So there's the practice test. And then after you take the practice test, if you struggle with any of it in particular, I took the same practice test. And here you can see I took all these problems. You can maximize it, of course. If there's any particular problem you had a trouble with, what are the possible rational zeros of this number 7? You can see where I went through, and I'll explain exactly how I do every single problem all the way to the end. So there you go, the Module 3 practice test. Then after you get that, you've got the actual test. Let's take a look at how many questions we got here. Divide by x plus 3. Divide by 3x squared plus 2. Ooh, so that's long division there. Looks like 10 problems on part 1. Oh, I like this. Which polynomial identity will prove that 6 plus 3 plus 6 squared equals 81? Might have to look, make sure the practice test has one of those, because we didn't talk about it necessarily in that way. We have to apply what we know. Part 2 has 2 problems. 2 problems. How to sketch an average rate of change. Slope. I'm going to go back and make sure that I have a problem on the practice test, like that into the one practice test. Let's go down to the bottom of this. There's only one band kit in here? Okay. How did Wes do? Yeah, I think I'm gonna do this one on paper just because we haven't done one like this in class. So I'm gonna launch this real quick. What polynomial identity should be used to prove that 35 equals 8 plus 27? And they give us sum of cubes, square of binomial, difference of squares, difference of cubes. Well, the first thing I'm looking at this, 35, well, let me write this down. So if we had this question, It says, can we prove this as difference of cubes, difference of squares, square of a binomial, or sum of cubes? Well, the first thing I look at is that's addition. So it can't be the difference of either one of those because there's not a difference. It's a sum, which makes me think it's this one. And this is a cube because this is 2 cubed and this is 3 cubed. And that is the sum of those. But I don't know that we looked at that formula. There is a formula called if you have 2 cubes like that, you can simplify it to a plus b. So yeah, I'm going to modify the test because we didn't have this. A squared minus ab minus b squared. There is a sum of cubes shortcut. If you have the sum of cubes, and that's again. If you have a the third plus b the third, it breaks down to a plus b times a squared minus ab plus b. That's a plus b. Now we did have something similar to that because we looked at squares of binomials. Similar, but this is saying, could you prove this with this? Well, if this was 2 to the third plus 3 to the third, would that equal 2 plus 3? Because that's what a and b is. 2 squared minus 2 times 3 plus 3 squared. Well, 2 plus 3 is 5. 2 squared is 4 minus 6 plus 9. 4 minus 6 is negative 2 plus 9 is 7. So this would be 5 times 7, which equals 35. Look at that. This did plan out the sum of cubes. The sum of cubes does show that 8 plus 27 equals 35 because we can use the sum of cubes formula. 2 to the third plus 3 to the third equals 2 plus 3. 2 squared minus 2 times 3 plus 3 squared. But anytime you see something like that, it asks you which one of these will prove that. You can actually use this mathematical theorem and just plug those numbers in to see that. But I'm going to change the test. So nobody take the test yet. Let me change that before anyone starts the test. If you start the test, you'll have that question. So don't start the test yet because I need to take it out. We didn't have that lesson. It was not there. We just had a review at 3.08. So that one's deceiving. But anyway, that's all we have this week, guys, the test. Give me 5 minutes to modify to make sure that I don't have a question of stuff that we didn't study on there. And then I'll turn it over and let you have it. But that's all we have this week is just the test and the practice test, of course. You can start the practice test now. That'd be good to do. And if you get to those problems at the bottom, don't worry about them. I'm not going to have that on the test because we didn't study. We studied a lot. We studied a lot of theorems in this unit with the fundamental theorem of algebra, Descartes' rule of signs, the rational root theorem, the factor theorem, the remainder theorem. We didn't need a sum of cubes on top of that, did we? Yeah, maybe, but that's okay. We didn't cover that just because interest of time. We can only cover so much stuff in this class, and we're packing a lot in this class already. So, anyway, you guys have a great week. This is an A-Day Friday, so if you get stuck and need some help trying to figure something out, come to class Wednesday, come Friday, whenever you need to be here. I will be here, and we can get things fixed. But anyway, have a great week. I won't keep you because I don't have a lesson for you. We just have a test this week. So have at it, and we will talk to you later. Have a rest of October. Fabulous time. Enjoy your Halloween. If I don't see you.